Hi there. All right. Today we're talking about 6.3, completing the square. Completing the square is a nice, helpful tool or trick. I think you might get frustrated once you see how easy it is, because in previous units, when we were interested from going from the standard form of a quadratic relation to the vertex form of a quadratic relation, we had to make a pit stop at factored form. Okay, so that was kind of like a really long process back in Unit 5. Now we can go directly there by completing the square. We don't have to go to factored form, and we also don't have to partial factor. So this is just kind of a nice little alternative to these lengthy, time-consuming methods that we used before. Before I show you how to complete the square, though, we have to do a nice little throwback to these guys. I hope you certainly remember what these guys are. We talked about them a lot in Unit 4. And actually, this was the very first instructional video I made, so it's kind of near and dear to my heart. These guys are perfect square trinomials. Okay, so let's do a nice little recap, because if you don't understand what those are and how to factor them, you will not be able to complete the square. So a perfect square trinomial is a trinomial where the first term's a perfect square and the last term's a perfect square, but you have to satisfy a certain condition for that middle term. So square root of x squared is x, square root of 9 is 3. When I times those guys together, I get 3x, and then when I double that, I get 6x. This is a perfect square trinomial, and look how easy these guys are to factor. Okay, square root of the middle term goes first. Square root of the first term goes first. Square root of the last term goes last. Make sure you throw it in a bracket and square it. And then sine of the middle term goes in the middle. Okay, I hope it's coming back to you. Let's do another one. Square root of 16x squared is 4x. Square root of 1 is 1. 4 times 1 is 4x, and when I double that, I get 8x. Awesome. Bracket. I always do the bracket squared first so I don't forget about it. 4x goes at the front, 1 goes at the back, and this sign goes in the middle. Okay? I certainly hope it's coming back. Let's do one more just in case, and switch colors so I can get use out of these new markers. Square root of 25x squared is 5x. Square root of 49 is 7. 5x times 7 is 35x. And when I double it, hello. So we can factor this guy so quickly. You go there. Okay? So perfect square trinomials can absolutely be factored using decomposition. It's just so time consuming, right? You want to have these nice quick little tricks to make your life easier. Okay, so why am I hammering on and on about perfect square trinomials? You will see shortly. Let's go with the first example of this note. This is a quadratic relation in standard form. My goal is to convert it to vertex form. Like I said, in previous units, we tried factoring, setting the factors equal to 0, finding the axis of symmetry, plugging it back in to get the y value of the vertex, and then stealing the a value from standard form. That method is fine. It's just very time consuming. We did something similar with partial factoring. These are all viable options, but I want to give you a method that is quick, okay, and more efficient. So this is a quadratic relation in standard form. What do I know about this parabola? It opens down. It's been vertically stretched by a factor of 4, and it has a y-intercept of 47. And now I'm done. Standard form doesn't give me any good information. I'm stuck. So if I want to convert this to vertex form, I have to, title of the note, complete the square. And it seems overwhelming, but it's the same process every time, so stay with me. What you're going to do is factor the coefficient of x squared from the first two terms. So what I'm actually going to do is recopy this stuff because I don't need it yet. Okay? Can you see that? There we go. Okay. Factor the coefficient of x squared. So the coefficient of x squared is -4. I'm going to factor it from the first two terms. If I divide both of these terms Okay, by negative 4, I am left with x squared minus 6x in the brackets. And people get all up in arms because they're like, Miss, why wouldn't you factor out an x too? They both have an x. I know, but just stay with me. Okay, so that's step number 1. Step number 2, you're going to recopy all this, and then you're going to leave yourself some space. Okay, now we are going to look at the coefficient of x inside the brackets, okay? That number is, let's get a different board here. Whoop. That number is negative 6. We're going to take a half of that, which would be negative 3, and then we're going to square negative 3, which is 9. Take a half and then square it. Now, we are going to add 9 and minus 9, okay? So a positive 9 and a negative 9 make 0. So for those of you that are thinking, how are you doing this? Why are you allowed to just add things into an equation? I'm adding 0, folks. When you add 0 to something, you don't change it at all. But we are now manipulating this to get exactly what we want. Okay. We are going to focus on these guys right here. Okay, I'm going to pull that out for a second. X squared minus 6x plus 9. Okay, so I added 9 and took 9 away. So basically I added 0, which I'm totally allowed to do. Then this looks kind of special to me, so I pulled him out for a second. Guys, this is a perfect square trinomial. Square root of this is x. Square root of this is 3. X times 3 is 3x, and when I double it, I get 6x. This guy can be factored like that. So what I'm going to do is take this and replace that with it. All right, so we've got y is equal to negative 4. I just realized this was a perfect square trinomial, and when I factored it, it looked like this. Okay, the thing is, I didn't need this guy. However, this guy is hanging out inside a bracket that is owned by negative 4. So if I want to take that guy outside of the bracket that is owned by negative 4, I have to multiply him by negative 4, which gives me positive 36, right? When we factor things, when we divide them, when we put them into brackets, and then if we're pulling them out, we have to multiply them together. This guy has not disappeared. Copy him. There is one more step in this process, and that is to collect these like terms at the end. And folks, we just converted a quadratic relation from standard form to factored form by completing the square. Okay, now I know exactly what the optimum value is. It's 83. I know that the axis of symmetry is the line x equals 3. I know all the transformations, and you know I'm going to spew them out because I love showing off. Reflection in the x-axis, vertical stretch by a factor of 4, horizontal translation 3 units to the right, vertical translation 83 units up. Okay, a minute ago we couldn't do any of that because we had no idea what this guy looked like. This is the beauty of completing the square. And we're just going to do a whole bunch more examples until you love it as much as I do. Okay, hello. This is a quadratic relation in standard form. I know that this parabola opens up, and I know that it has a y-intercept of 0, and that's all I know. That's not good enough. If I want the vertex, I'm going to have to complete the square. So let's go back to those steps from a minute ago. Factor the coefficient of x squared from the first two terms. This is kind of an easy one. There is no coefficient of x. There's an invisible 1 here, which means we get to skip directly to the next step. The next step says, look at the coefficient of x. Okay, so let's go ahead and do that. That number is negative 8. I want to take a half of negative 8, which is negative 4, and then I want to square negative 4, which is 16. And so I am going to add 16 and minus 16. Am I allowed to do that? Absolutely, because a positive 16 and a negative 16 is just 0. I can add 0 to the equation, and that is totally okay. And I didn't just do it for fun. that was a very strategic move because I just created a perfect square trinomial, okay? Let's make absolutely sure of that. So this is what I have. Square root of x is x squared. Square root of 16 is 4. 16 times, oh my gosh, you guys, I'm sorry, it's very late. X times 4 is 4x, and when I double it, I get 8x, which means x goes here, 4 goes there, and this guy goes in the middle, okay? So we've created this perfect square trinomial. And then, what about this guy? This guy wasn't a part of it. Okay, in the previous example, we were pulling him out of a bracket, so we had to multiply him by a number, but he's not in a bracket. He's just existing, and we're done. We're done, okay? Your goal is to wean yourself off of this step, all right? And once you do enough of these examples, you won't even need that sort of middle step. Okay, so let's do another one. That is a quadratic relation in standard form. I know that the y-intercept is 5, and I know that it opens up, but I have no idea what the optimum value is. And that's our goal today, to get this to vertex form. So factor the coefficient of x squared from the first two terms. There is none. Awesome. Let's go directly to the next step. The next step says, look at the coefficient of x, it's -3. Cut it in half. So that's -3/2. And this one gets a little uglier because the numbers are not as friendly, but that's okay. The process is exactly the same. Then we're going to square that. Okay, remember when you square a fraction, you square the top term that goes on top and square the bottom term that goes on the bottom. Of course, when we square a negative, we get a positive. So 9/4, we are going to recopy those first two terms. We are going to add 9/4 and minus 9/4 and copy that +5. We don't need it yet. Okay. What we did here, even though it doesn't look like it because it's so ugly, is we have created a perfect square trinomial. And I'm wondering in the previous steps if you noticed that the number that goes inside the bracket in the previous examples has happened to be this guy. Okay, so that goes in the bracket. And now I just have to collect like terms here, which I can do on my calculator using the fraction button, which I don't have out right now. And that works out to be 11/4. So a minute ago, all I knew about this quadratic relation was the direction of the opening and the y-intercept. Now I know the vertex. 3/2, 11/4. Okay, the only way to get comfortable with this is to do a million examples, so let's keep going. We have a quadratic relation in standard form. The only thing we know about this parabola is that it opens up, it's been vertically stretched by a factor of 5, and the y-intercept is -11. That's not good enough. Okay, I want the optimum value. So factor the coefficient of x squared from the first two terms. The coefficient of x squared is 5. So I'm going to factor 5 only out of the first two terms, okay? And then recopy this guy. We're not using him just yet, okay? In the previous two examples, we didn't have to do that because there was no coefficient there. Now we're going to move on to a more difficult example. Okay, now recopy that, but leave yourself some room. Okay, now we look at the coefficient of x, which is 2. Okay, remember off on our second board here, we take a half of 2, which is 1, and square it, which is 1. And we are going to add 1 and minus 1. Okay, now we have strategically created a perfect square trinomial. Okay, and again, I'm going to use that board to prove that to you. X squared plus 2x plus 1. Square root of that is x. Square root of that is 1. X times 1 is x. Double it, get 2. This is just so fun. So I get x plus 1. Okay, so I'm going to replace that perfect square trinomial with the factored version of that perfect square trinomial. And now, guys, he was not part of this, okay? He was just kind of waiting outside the wings. He belongs to 5. 5 owns this bracket. If I'm going to pull him out of that bracket, I have to multiply him by 5. That's one of the most commonly made mistakes is kids forget if you're pulling that out of the bracket to multiply it, so just be really careful. And now I collect like terms, so I get 5x plus 1 squared minus 16. Okay, this is awesome. Now I know the vertex is -1, -16. I know the transformations. If I was in grade 11 functions and I had to graph this, hint, hint, you will be doing that next year. I could make a transformation table. Okay, all the good stuff lies in vertex form, and completing the square gets me there in 3 steps. And hopefully you get to the point, folks, you can actually do this in 2 steps. And versus what we did back in Unit 5, where you had to factor and set the factors equal to 0 and blah, blah, blah. Okay, hopefully you see a pattern emerging and you're feeling more comfortable with the steps. So I'm going to try to work through this one a little bit quicker. Factor the coefficient of x squared from the first 2 terms. Be careful with signs. Okay, so all I did was divide the first 2 terms by -12. I understand they both also could have been divided by an x, but that's not part of the process. Now we look to the coefficient of x, which is -8. Whoop. I'm going to cut -8 in half, which gives me -4. And then I'm going to square -4, which gives me 16. And I'm going to add 16 and take 16 away. Why did I do that? Because I've created a perfect square trinomial right there. When I factor that perfect square trinomial, folks, whatever the half of b was is what goes inside the brackets. Okay, now I'm going to recopy. Okay, this guy's going to come out of the bracket, but that bracket is currently owned by -12. So in order to pull him out, I have to multiply -16 by -12, which gives me 192. And don't forget about him. He's just been hanging out till our very last step where we can collect like terms. Okay. Reflection in the x-axis, vertical stretch by a factor of 12, horizontal translation 4 units to the right, vertical translation 198 units up. Okay, I'm going to skip example number 4 because I'd like you to try that one on your own. And as always, I am totally available to you for questions on EDSB. We're going to go right to the word problem. So in the word problem, we talked about minimizing cost, which is what every good entrepreneur wants to do. So they give us a relation to model the cost. There we go. And it's in standard form. So it says the cost to hire landscapers to weed and seed a park can be modeled by this relation. X is the number of landscapers hired to do the work. How many landscapers should be hired to minimize the cost? I see the word minimize, folks, and my brain goes vertex, 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 okay? If I'm sitting here at standard form and I want to get to the vertex, not only because the title of the note is called completing the square, but the most efficient way to go from standard to vertex is to complete the square. Here we go. Factor the coefficient of x squared from the first 2 terms. Leave yourself some room. Okay. Look at the coefficient of b, -10. Half of that is -5. -5 squared is 25. We are going to add. No. Okay, let's try a different marker. we are going to add 25 and minus 25. When I did that, I created a perfect square trinomial that can be factored as such. Square root of x is x, square root of 25 is 5. This sign goes in the middle, bam, okay? I'm going to copy this guy because he doesn't disappear. He wants to leave the bracket, but the bracket is owned by 6. So in order to release him, we have to multiply him by 6, which gives us negative 150. And you, I recopy because you're just sitting here waiting your turn. Last step, collect like terms. Okay? Why did I do this? Because now I know if I hire 5 landscapers, I can minimize my cost to $750. Okay? A minute ago, I didn't have that information. When I convert to Vertex form, I get all the good stuff. Do I know the break-even points? And that's a nice little throwback to a unit we already did. Okay, do I know the break-even points? No, because I don't have any information about the zeros. Okay, I didn't go to factored form. However, if I want to look at my optimal scenario, right? Number of landscapers to hire, cheapest cost, this is going to achieve that for me.